So magma is the molten rock which is inside the body of the earth. Magma forms when rock melts deep beneath earth's surface. So the molten rock which remain buried inside the body of earth, that is called as magma. And when this magma, it rises and comes to the surface of the earth and erupts in the form of volcanic eruption, and it flows on the surface, then it is called as lava. So this is a slight distinction between these two terms, magma and lava. Both of them corresponds to the molten rock. One, magma, is in the interior of the earth. Lava is the one molten rock that flows on the surface or comes on the surface of the earth after volcanic eruption. So another question that comes to mind is why magma is rising. So another very important term is called, it's called buoyancy. So this is a very important term. I want you guys to understand that buoyancy is the process when two liquid masses of different density they mix together, then the lighter mass will rise toward the surface due to density contrast. So this is a very important term, density contrast. The lighter mass will rise towards the surface. So if you have a beaker here and suppose you have two different liquids, suppose this is another, you can think of it as vinegar and oil. So whichever one is lighter, oil is lighter, it will starts to rise toward the surface due to this density contrast. So density, I hope you guys know this term. Density is nothing but mass per unit volume. So it tells you for a given volume. So suppose a beaker which is 1 liter in volume, if you fill that beaker with different material, different objects, then how much does it weigh? So that is the density. So you can think about the density of iron is much heavier than density of water or density of cotton. So that is a very significant contrast in density between these two objects. But these two are again solid material. When we are talking about buoyancy, then we are talking about liquid material. So as here you can see magma, it's a molten rock, so it is in liquid phase, but it is lighter than the surrounding rock. The rock around it, it is much heavier than the molten rock. So this magma being lighter in density, it has a tendency to rise towards the surface of the earth, and depending on how much pressure it is, it will continue to rise, and then it will break through this surface through the opening of on the surface of the rock in the form of volcanic eruption. So and then it will be called as lava once it lands on the surface of the earth. So then once the lava comes on the surface, it goes through the process of cooling and crystallization. You must have learned about crystallization in the last chapter, where you looked at how these different minerals are forming at different temperature and different pressure. So think about this condition in the interior of the earth when the magma is buried. It is under extremely high temperature and extremely high pressure. So if you think about the interior of the earth, so it is, suppose this is okay, so this is suppose earth interior. If you go in the depth, the temperature and pressure both are increasing, right? As you go deeper and deeper into the earth, in the interior of the earth, both temperature and pressure are increasing. So this magma, as it is rising toward the surface of the earth, the temperature and pressure both are decreasing. It is rising towards a cooler environment, and an environment which is weaker in pressure as well. So it will continue to rise, and this change in the environment will lead to different process of crystallization. This will allow different minerals to form, different minerals to crystallize, and eventually when it reaches on the, so there are two options, right? One is, okay, so this magma can solidify in the interior of the earth, so, or on the exterior, right, or which is also called as on the surface, right? So suppose this is your interior of the earth, this is your magma chamber or pool of magma, and it is rising up. But here, suppose in the interior of the earth, it came across a very strong solid layer of the earth through which it cannot break through. It cannot break through this strong layer of rock, right? So in that case, this magma will start to solidify here, right? So this one will be called as igneous rock, right? Due to solidification of magma or lava. So igneous rock is a rock that forms due to solidification of magma or lava. So the igneous rock could be intrusive or extrusive. Two different types. Intrusive, when it solidify in the interior of the earth, and the extrusive is when it solidifies on the surface of the earth from lava, right? So that is due to solidification of lava, and this is due to solidification of magma, right? So two different types of igneous rocks: intrusive, extrusive. Intrusive is one that forms due to solidification of magma in the interior of the earth, and when this magma is able to erupt, comes out on the surface of the earth, something like here. So something like here, if you have this lava, it goes through solidification and then it will become igneous rock. So this will be extrusive, right? And this one is an intrusive igneous rock. This one you can say intrusive igneous rock. Okay, so these are so that is what explained here. Extrusive igneous rock, you can see due to solidification here, somebody is taking measurement, it is taller than an average human height, 5-6 feet taller than that. So this is how much lava which erupted on the surface and then gone through this process of cooling and crystallization, and then it become an extrusive igneous rock. Okay, and then this is an example where the magma could not break through the crust of the earth, and it solidified in the interior of the earth, and then it is called as intrusive igneous rock. Okay, and this one you can say this process is going through this rock, the intrusive rock can go through the melting process again. So this intrusive rock can be now further buried deeper due to the overburden pressure. As more and more layering of the rock forms on the surface of the earth, this layer, this intrusive igneous rock, will continue to bury deeper in the earth crust, and as it goes deeper, what happens? It will be exposed to higher temperature and pressure region, and that higher or increased temperature and pressure will try to melt this rock, and this will go through the melting process and become magma again. So here you can see right here, it doesn't even have to transform into another rock. The igneous rock itself converts back into magma and then form a new type of igneous rock. Okay, it may again break through, or it may again be solidified in the interior. So that is again a small cycle within the cycle here. So okay, so the next process, so when the igneous rock is formed either on the surface or the interior of the earth, the intrusive igneous rock in some instances to the uplifting process can be exposed on the surface of the earth. Just by itself, intrusive igneous rock is buried in the interior of the earth, and it is not exposed to the weather element. It is not exposed to sun, it is not exposed to rain, it is not exposed to wind or river or glacier action. It is not exposed to any of those weather elements. So it remains protected from the weathering process. But due to uplifting process, that is another geological event. During some time, the earthquake event, the earth crust is sometimes turned upside down, or it completely blow open the earth interior, and that can bring some of these earth intrusive igneous rock being exposed on the surface of the earth. So there are some examples in the state of Washington, in the state of Colorado. You will see lots of these igneous rock which were formed as an intrusive igneous rock, but due to some geological event they were exposed out on the surface of the earth. Okay, so now the next major process of transformation in rock cycle is called weathering. Weathering is the process where a large piece of rock is broken down into smaller pieces, and those smaller pieces are called as sediments. So weathering, as it defines here, weathering breaks down rock that is transported and deposited as sediment. So here I will just write it down. Weathering, it is into smaller sediments, okay, which are transported by weathering agents such as river. I want you guys to memorize this, the weathering agents. This is very important. This may be in your exam. So weathering agents are river, wind, glaciers, wave action. What else is there? There's more in your textbook. So these are the four major weathering agents: river, wind, glacier, and wave. So when these rocks are exposed to these weathering agents, like if a river is flowing over a rock, it will over the time it will continue to erode or break that rock down. And the same thing by wind. As the wind is blowing over an exposed mass of rock, it will continue to weather it, break it down into smaller sediments, and then carry it forward. And glacier would do the same. Waves had the similar effect on rocks. And the river, winds, glacier, wave, they also do the transportation part, right? So they not only break the rock into a smaller piece, but they also transport them from one location to another. So that is the complete process of weathering, where it breaks it down, where the large mass of rocks are broken down into smaller pieces and then transported by these weathering agents. So here So that is one process, weathering. And then another process is lithification, where the loose sediments are compacted and cemented. So there are minerals. So think about this. Okay. So you have these loose sediments now, right? So think about this. You have all these loose sediments here. Um, and then you have water flowing through them, right? These are small pores through which water is flowing, right? And these water have some chemical species, right, dissolve in it. So this is not the natural water, the water which is flowing in the river stream. It's not just pure H2O, but it has some dissolved species in it, right? And these dissolved species has sometime calcium carbonate, which has a cementing property, right? So we know that calcium carbonate, we use it to construct home. The dry walls, those are made up of limestone. So it has a strong cementing property. So these chemical species have some of these cementing or bonding properties. So when these water flowing through these pores in these small sediments, they will start undergoing some kind of chemical reaction here, right? And that will start to bond these loose sediments into integrated solid cohesive rock masses. So and then another process is compaction. So before cementation, over the weight, over the underburden pressure, right? So over the time, you have more and more layer of these sediments forming, and as you have more and more layers are forming, that will cause compaction, right? Due to the overlying pressure, there will be compaction. So that will reduce this pore size, so they will compact it together. And when this water is now flowing through these tiny pores, they will start or trigger some of these chemical reaction, which will cause this lithification. So this process is called as lithification. And lithification is a term, it's a combined term for both compaction plus cementation. So it's a single term which includes both of these processes, compaction and cementation. So make sure you remember these terms. Lithification, it defines or explains these two processes, compaction and cementation, during the formation of sedimentary rock from loose sediments. So how these loose sediments transform into a complete cohesive rock. So that is a type of rock, a new type of rock. So the igneous rock, when they were exposed to the weathering process, here you can see the igneous rock has been exposed to weathering and transportation and deposition. And now these deposited sediments will undergo lithification, which is compaction and cementation, and they will form a new type of rock called sedimentary rock. So this is your second type of rock in the process or in the cycle, in the rock cycle. So igneous rock can transform into sedimentary rock. And now again, this can again go through uplift, weathering, transportation, and deposition. These sedimentary rock, they themselves can be exposed to the weathering agent, right? So once they are formed a rock, now if they are on the surface of the earth, they can be exposed to the weathering agent, and they can again convert back into sediments. And then there is another small cycle inside the rock cycle, you can see. So just like igneous rock had a little cycle inside, so sedimentary rock also has its own cycle, where this sedimentary rock can keep on going back and forth between sediment and sedimentary rock. Okay, so now going forward, here it is another transformation process called metamorphism. So this is about this this layer of rocks. So we saw that igneous rocks, or these are the layers of different rocks we have, right? It can maybe igneous, sedimentary, or metamorphic. So we understood so far igneous and sedimentary rock. Now we will talk about metamorphic rock. Okay. So over the years, what happens? These sediments will continue to deposit on the layers, and new layers will continue to build over time. And what will happen? This will continue to force these layers deeper in the interior of the earth. So due to overburden pressure. So these interior layers will continue to go or buried deeper and deeper into the earth. And just remember, as we go deeper in the earth, the temperature and pressure will increase, right? And this increased temperature and pressure will now start to transform this rock. One thing that will happen is compaction. Due to increased pressure, the sedimentary rock or igneous rock, which is in the layer, as it is exposed to higher temperature and pressure, this will increase the compaction. So they will be compacted, and sometime due to increased temperature, due to much higher temperature and pressure, a new chemical reaction may be triggered in the depth of the interior of the earth, and that can start to transform this igneous or sedimentary rock into a third type, a new type of rock, and those are called as metamorphic rock. So that is how this third type of rock is formed, called metamorphic. And metamorphic, as its name indicates, it means changes, metamorphism, due to the change in the original rock. After being exposed to higher temperature and pressure, it's now transformed into a new type of rock called metamorphic rock. So let's go back to your schematic here. Metamorphism due to heat and intense pressure. When sedimentary rock is buried deep in the crust, heat and pressure or stress change it to metamorphic rock. And here it is. You can see this third type of rock called metamorphic rock is formed due to intense or increased heat and pressure in the interior of the earth. And this again be exposed by process. These rock which is in the interior of the earth can be exposed now on the surface by the process of uplifting, which is a geological event in which the deep buried rock are brought up on the surface of the earth, and now they are exposed to the weathering, transportation and deposition. So this can start forming the sediments, and then the sediments will again go through lithification, form the sedimentary rock, and those will be further buried deeper in the earth and can convert into metamorphic rock. Okay. And the metamorphic rock itself go through even much deeper, they can be buried even much deeper, and they can go into higher degree of metamorphism. So one metamorphic rock, so we will look more in detail the different types of metamorphic rock based on the degree of metamorphism that is exposed to. So here this is small circle here, it shows that the metamorphism can be applied on an already metamorphic rock. So it can go through even further process of metamorphism. And then again, as this metamorphic rock goes deeper in the earth, it can melt, and that will give you the magma, and the magma, then the cycle completes here, right? So this is where we started with the magma, and once we start forming magma again from after these rocks are buried deeper, as they continue to go deeper in the earth, they are continue to exposed to higher temperature and pressure, and at certain depth, at a certain temperature, the melting of the rock will trigger, and that melting will start forming magma or magma chamber, and then magma being lighter in density, it will start to rise toward the surface of the earth. So this cycle will complete here, and this is how it will continue. So you have all of these different processes of transformation that transform rocks from one type to another. So let's just quickly go over the slide here. So this is about rock cycle. So definition of rock cycle, it describes the interaction between the components of the earth system, origin of igneous, sedimentary and metamorphic rocks, and how they are connected. So that's how the rock cycle describe the connection between these three types of rocks and how they transform from one type to another. Any rock can be transformed into any other rock type under the right conditions. Magma, lava, within the crust, the molten rock is called magma. On the surface of the earth, this molten rock is called as lava. So make sure you remember, you understand the difference between magma and lava. This is very important. It may be in your test, and remember the difference between two types of igneous rock. The one that forms in the interior of the earth, those are called as intrusive igneous rock. The one that forms on the outside, on the surface, those are called as extrusive igneous rock. Weathering, remember the definition of weathering.